Okay, so let's talk about scientific notation. So I have a pretty simple question here. Which of these is easier to use? This number or this number? Or, Lord help us, this number or this number? Okay, so this gives you a very simple illustration of why we use scientific notation. So scientific notation is a way to show very large and very small numbers easily. It's all based on the powers of 10. As you can see, both of your numbers on the right here, you have a power of 10, right? So you have a power of 10, 10 to the 14th here, 10 to the 11th here. Okay, pretty straightforward. Based on the powers of 10, um, and it will be in this form, a times 10 to the b. These have specific names, and you should know them. So a is going to be any non-zero number. We can have a decimal point. You'll see probably more often than not, we'll have a decimal point. This is called the coefficient. That's an important term. So remember, this is your coefficient over here. Coefficient, coefficient. B is any whole number for our purposes. You can have, decimals for your exponent, but for us, we will have a whole number exponent. So here you have 10 to the 14th, here's 10 to the 11th. Okay, so that's the basic format. Here's some examples. There are literally infinite examples that we could put forth, but you can see all of these have a coefficient, okay, and then times 10 to a power. Okay, so that's how they're all going to work. All right, how to convert. This is something I'm sure you've done at some point in your life, and it's going to sound a lot more complicated than it is, so just bear with me while I try to describe it, and then the best way to learn this is just to practice. So how do you do it? You take your number and you find a decimal point, okay? So sometimes there is no decimal point, all right? So, for example, this number. So there's no decimal point here, but that's okay. We know from basic mathematics that the decimal point, it's implied, it's all the way to the right. So if there is not a decimal point, you know that there's a decimal point there at the end. Okay? So first thing, find the decimal point. So what we're going to do is, and this sounds way more complicated than it is you're going to sort of quote unquote move the decimal point until it's to the right of the last non-zero number to the left. What does that mean? Well, in this case, we're going to move it over to here. All right? So we'll go through examples to show this. But what you want to do is when you move it, you want to count how many numbers you've moved, okay? If you move to the left, as you do with a large number, like our example here, then that's going to be a positive exponent. If you move to the right, that means you have a really small number that you're going to have a negative exponent. And then you just drop any zeros to the right, okay? So let's just do some examples. Like I said, this is the easiest way to go. So here's our standard notation, 100 watts. So to convert this, it's implied that the decimal point is here, so we count over 1, 2. So it's 1, and remember, you drop all the zeros to the right, so it's 1 times 10 squared watts, and that's it, okay? So here, decimal points here, 1, 2, 3, 4, 5, 6, 7. So it's going to be 2.5 times 10 to the 7th joules. Very straightforward. Decimals here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it's 9. Now you keep any non-zero number here, so it's going to be 9.003 times 10 to the 11th BTU. Okay? All right, so these are all big ones, so we've moved to the left, and so we have positive exponents. So let's look at one where we move to the right. Decimal points here, 1, 2, 3. Okay, so we're moving 3, but we're moving to the right, so it's 4.2 times 10 to the minus 3 joules. Okay, this is where people can get a little tripped up. The way I think of it is, this is a big number. I think big is positive, so positive exponent. I think small is as a negative. However you want to remember it. So let's do the next one here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 8, and we don't have anything to the right of it. It's 8 times 10 to the minus 11th seconds in this case. And the last one here, see if I can reach all the way down. 1, 2, 3, 4, 5, 6, 6. So we stop at the last. We stop when we hit a non-zero number. So that's going to be 7.0005 times 10 to the minus 6 meters. So you can see all of these. We have one number to the left of the decimal. We're going to stop there. Now, just to be clear, it's not technically incorrect if you would have, say, 7D.005 times 10 to the minus 7th. You can do that. It's technically correct, but for now, we'll just keep it to one decimal to the, one number to the left of the decimal. Okay, so that's really, pretty straightforward. One thing I do want to point out is that a lot of times, so like this, for example, 1 times 10 squared, a shorthand way to do this, you'll see 1e2 or 1e2. Keep our units here. Okay, so this is basically because I use this when I'm typing a lot because it's a lot easier than making things a superscript. So like this would be 2.5 E7. Okay, so you'll see that notation a lot, just so you know. So let's do, we'll go back in the other direction. So going from scientific to standard notation. So all you're going to do is find the decimal point. You're going to move, you're going to sort of do the process in reverse. So you take into consideration the power of 10. Okay, if it's a positive power of 10, you're going to just take that decimal point and move it to the right. If it's negative, you're going to move it to the left. Make sure you add your commas. Okay, so let's just do a couple of quick examples. So we have 2.5 times 10 squared. So we have a positive 2, which means we're moving 2 to the right. So 2, 5, so we're going to go 1, 2. 250 watts is going to be standard for that. So this is a, okay, so that's, sorry, that should be, is that a minus? It looks like it's kind of messed up. So we'll just say that's positive. Okay, so we'll call this 10 to the minus 8. So we're going to move this 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be, let's write it out, 9.053. Okay, so minus 8. So 1, and then we're going to go 7 more zeros. So 1, 2, 3, 6, 7. So it's 1, 2, 3, 4, 5, 6, 7. Put our decimal place there, okay? And that's going to be meters. 1.7 times 10 to the 12th. So we're going to take this and move it over 12 spaces or places, which means we have 1 and then 11 more. So 1, 7, then we have 11 zeros. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11 BTU. Do not forget to put your commas in. That's really important for these large numbers. Okay. Try this one. So we're moving 8 places over. So 1, 2, 3, 4, and then we need 4 more zeros. So 3, 0, 0, 0, 5, and 1, 2, 3, 4. Don't forget your unit, TOE, comma, comma. And the last one here, we're going over 2 places. Oh, I see what happened. That's okay. 250 watts, same as before. Okay, so that's how you go from scientific to standard notation.